Good afternoon. My name is Nat Solstrom. I'm the Director of Amazon Energy at Amazon Web Services. I want to start by asking you guys a question. You can respond in the affirmative with a show of hands. How many of you in this room are here attending reInvent for the first time? Is it cool? That was really muted. Yeah! Yes! I'm really pumped up. And I got to tell you guys why I'm very pumped up. I have been at Amazon nearly 8 years, and I love my job. I have one of the coolest jobs in the world. There's one little bit of dissatisfaction. I hadn't been to reInvent yet. This year I got invited. I'm really, really excited to share some stories with you guys today about the foundations of AWS cloud infrastructure. I'm going to be talking about regions and AZs and our networking gear and how we innovate on behalf of our customers. But I want to share with you a little bit about something that's very near and dear to my heart, which is energy. You can see that in my job title. And one of the things I'm going to be talking about is how we innovate, not just in our features and services, but also in our infrastructure. How we power our data centers, how we cool our data centers, how we engineer our data centers around the world to provide the highest levels of reliability at the lowest costs wherever you, our customers, need them. So I hope you guys are excited as I am. I'm going to jump right in, though. AWS has millions of active customers. As you well know from being here and walking the streets in Vegas, AWS is a large and rapidly growing company. In fact, in Q3 2018, revenue for the AWS segment at Amazon increased 46% year over year, making AWS nearly a $27 billion run rate company. That's truly amazing, and thank you for that. We could not do it without you. In fact, AWS is the fastest enterprise IT company to ever reach a $10 billion run rate. So you can see all these customers growing as we started the business back in 2006. But something that's interesting as well is outside of this customer growth, you're also seeing a pace of innovation that's growing just as rapidly. And I don't need to tell you guys this because you're here at reInvent and you're seeing all the announcements that come out. But this statistic is something that's worthwhile to go look back on. In 2008, 24 new capabilities. Look where we are in 2017. 1,430 new features and services for AWS customers. And we're on top to beat that in 2018. Pretty amazing. What is more interesting to me, though, outside of just these features and capabilities, is how they are created. At Amazon, we start with a principle called everything works backwards from the customer. And the really, really cool thing that is implicit in this chart is that 90 to 95% of these new capabilities and features and services are driven directly by customer feedback. Customers asking for this feature, this service, and we listen to you. We develop and deploy them as rapidly as we can. And I'm about to show you a big map of AWS's global scale. But scale lets you do some really, really cool things. You probably know in this room that computers cost a lot of money. Servers cost a lot of money. And I can tell you what, power costs a lot of money. Switchgear and substations and data centers and fiber networks cost a lot of money. But when you have scale, you can do some really cool things to your cost structure. And at Amazon, we look at this scale in perspective of a virtuous circle. Lower cost. Lower cost we can do some really cool things with. One of my favorite things that we do at Amazon with lower cost structure is pass our savings on directly to you, our customers. In fact, since 2006, AWS has reduced prices 67 times. Think about that. Can you think of any service that you use in your life where they've reduced prices 67 times? As I prepared to share this story with you guys, I was like, man, that is a very difficult thing to find. And in addition, you get more value for that service as well. The other really cool thing you can do with a lower cost structure is invest in better capacity for your data centers and your infrastructure. That in turn drives higher degrees of reliability for our customers around the world. Where around the world? Well, let me show you. This is AWS's Regional Expansion. I started out at AWS in 2011 when we had 4 regions. You can see the pace of growth here over the 7 regions to 8 regions to now having 19 geographic regions around the world. The AWS Cloud operates 57 availability zones within those 19 geographic regions around the world. In fact, AWS has announced plans for 15 more availability zones in more regions in places as diverse as Bahrain, Cape Town, Hong Kong, Milan, and Stockholm. These regions will be coming online between now and the first half of 2020. There's something implicit in this story, too, that's worth noting when we talk about the foundations of AWS's cloud infrastructure. Nobody has more experience operating a global cloud network than AWS. It is not a trivial problem to find out where to build and operate data centers in Stockholm, in Milan, in Singapore, in Hong Kong, in San Francisco. And the AWS infrastructure team has found ways to do that and will continue to do so. That was a global map. And I want to spend a little bit of time walking into the anatomy of what an AWS region looks like. And there's an important reason for doing this. We recognize that customers have a lot of choice with who they use as their cloud provider. And a really important thing to realize is when AWS talks about their regions, we're talking about something very specific. From time to time, you'll hear other cloud operators talking about having a region in a country or in a part of the world. And it's important to know that that sometimes can mean just one data center. I'm going to explain to you what an AWS region means in a country. And hopefully when I'm done doing that, you will have a high degree of confidence in the reliability and capability of the AWS region model. With that being started, it all starts with the availability zone, or AZ. An AZ is a very important concept for us. Each availability zone is a fully isolated partition of our infrastructure. Well, what do I mean by fully isolated partition of our infrastructure? Well, first of all, it's physically separate. Not in the same building as other availability zones, not even across the street. It's separated by meaningful distance, at least a mile, or in many cases, many miles. And we design each availability zone to have its own power infrastructure. I'd ask you to put that thought into a parking lot because I'm going to be talking more about power infrastructure, but I can tell you how critical power infrastructure is to data centers. In addition, these AZs are big. They can be multiple data centers. A full AZ can have hundreds of thousands of servers at scale. This is what a lot of providers call a region. But for AWS, this is our most basic building block. It all starts here. And you can see I have an AZ illustrated on this slide. This availability zone is made up of 5 distinct data centers. The data centers are in an availability zone, and they are connected by fully redundant and isolated metro fiber. Now, I'm going to be talking a little bit about the fiber nets that connect our infrastructure, but one way you can think about this as the roads within your city or town where you live. And some of this metro fiber that connects the data centers within the AZ are kind of like the side streets. Most AWS regions have 3 or more AZs. Some have as many as 6. Now, I want to pause for a second. Before we wire up all these AZs, I want to explain why I'm making such a big deal about availability zones. Availability zones, as their name implies, are very powerful tools for building highly available applications. If you partition your application across availability zones, you can better isolate your customers from any issues. What kind of issues? Well, as I finish up this kind of lesson around AZs and regions, we go to great lengths to build redundancy into our regions. We all live on Earth. And on Earth, anything can fail. Lightning can strike, 100-year floods. And oftentimes, I like to think about Godzilla coming down from Godzilla 1985 and stomping down on one of our data centers. And what were to happen if Godzilla were to strike one of our data centers? Well, if you're partitioning your applications across an availability zone, you won't know. It's as easy as that. You see, all these AZs are interconnected with high bandwidth, low latency networking, which means that your applications are sound and reliable. Let's take a look at that. So, within an AWS region, all these AZs are connected with fully redundant, isolated metro fiber, as I pointed out earlier. This provides high throughput, low latency networking to and from these different availability zones. And it also provides a high degree of availability in event of Godzilla strikes. Now let's connect these to the rest of the world. Each region is connected to 2 independent transit centers. Now, if you recall, I used a street metaphor. Within the AZs, you'll see the back streets. Then you'll see these purple lines, which are the inter-AZ connections, which you can think of as some of the highways. And the transit centers are the freeways that connect regions to the rest of the world. So as you can see, we have a lot of redundancy built into an AWS region. And we will do everything we can to make sure that you never, ever see a failure. And if you make use of availability zones, you can achieve even higher degrees of availability. And on top of that, we need to add in all the points of presence, or POPs as we call them. These are highly connected edge locations that are used by CloudFront and AWS to peer with eyeball networks all over the world. Today, we have 150. And just like our regional footprint, we are aggressively expanding our POP footprint around the world. And here's how it's all connected. All of these regions and all of these points of presence are connected by the Amazon Global Network. The Amazon Global Network provides private connectivity between all of these locations via a redundant network. What you see pictured here is some major links in that network. Each one of these is, in many cases, 100 gig links. So that's kind of an abstract picture of what the AWS infrastructure looks like. I want to share with you guys a little bit more about the AWS infrastructure from where I see it. And what I'm talking about is not abstract AZs or regions, but building and powering actual data centers around the world. How do we do that? How do we think about that? Well, I can tell you that the spirit of innovation, pioneering, and cost savings percolates through everything we do at AWS, and building regions and building data centers is no exception. A high degree of planning goes into building data centers. As I mentioned earlier, everything at Amazon starts with the customer, and we work backwards from there. So one of the first things we think about in a region is there customer demand? Do customers want us to be in this region? Well, once you've figured that out, you actually have to think about how do we plan for, design, and build data centers in regions as geographically diverse as Bahrain, Sweden, Cape Town. I can tell you firsthand that planning, buying land, and building a data center in rural Oregon in a wheat field is a very different challenge than building, designing a data center in downtown Tokyo. Nonetheless, the challenge for the AWS infrastructure team is always to have the highest degrees of reliability for our customers, no matter where we build these regions. These regions also require high degrees of power infrastructure. Power, as I mentioned earlier, is the lifeblood of the modern data center. Without power, you just don't have a data center. So oftentimes it's really interesting. My friends and family will be on road trips with me. I've been in Argentina on a bicycle. I've been riding around on a bike in Italy. I've been on a boat outside of Spain. And one of the things I'm always on the lookout for is high voltage power lines and substations. And that makes me kind of a That's my sightseeing experience for me, because I'm always looking for those, because we need to have the highest degrees of reliability for our power infrastructure, for our data centers. And when I talk about scale, the image that you see here is an HV transmission line. That is very much what we are looking for, because in many regions, AWS data centers are some of the bigger users of power. And that big power use comes with some benefits. A lot of them are linked to the fact that AWS has a commitment to renewable energy resources. And in many parts of the world, our commitment to renewable energy resources can sometimes present challenges that we have to work around. So our team has developed innovative commercial energy contracts. So again, the spirit of innovation that you guys are seeing at reInvent with all the services and new features that we're launching, I'm here to tell you today that percolates in everything we do. We have worked with utility commissions, utilities, regulators to find ways to bring that spirit of innovation into commercial contracting. Now that might sound a little bit boring to think about working with a regulator and a public utilities commission, but I can tell you it's really impactful and exciting work when you think about how we can actually transform the power grids where we have physical infrastructure. And when I talk about transforming, I'm talking about bringing hundreds of megawatts of renewable energy to regions in the world where it previously did not exist. AWS made a commitment to 100% renewable energy. And I'm really proud to tell you that we're making a lot of progress in that space. In fact, in January 2018, we achieved 50% renewable energy, and we are not stopping. We also recognize that transforming from a carbon-based energy to a renewable energy future is going to require more than just wind farms. It's going to require more than just solar. And let me start with the really, really simple heuristic. If you have a grid that is truly powered by 100% renewable energy, what do you do when the sun is not shining? What do you do when the wind is not blowing? Well, one of the early elements that energy experts are working on to solve that problem is storage. And that spirit of innovation and experimenting, you see that with storage in AWS, in that we partnered with Tesla to do a 4.8 megawatt commercial battery pilot storage program. At the time, this was the largest storage project that had been done to date. In addition, you'll see that there's a keynote session here at reInvent this week where we're talking about how we worked with EDF to help them manage their solar resources. All of those three different elements using AWS software to help manage and dispatch renewable energy resources, investing in renewable assets, looking at emerging technologies like storage, are all going to be part of the puzzle to solve towards getting to a renewable energy future. In addition, it is not going to be simply AWS. Some of the other things that we work on is we have a policy team that works very closely with the AWS Infrastructure team to make sure that we are trying to influence outcomes that make it easier for renewable energy to be deployed and developed around the world. So you'll see our contribution in board seats to organizations like ACOR, the Advanced Energy Buyers Group, and you will see more AWS participation in this type of work in the future. So, I want to tell you guys a story about the first project that we developed. And this one is really cool because it's your first one. It's the first one that Amazon did, so it's kind of like your firstborn, so you have a lot of fond memories and a lot of learning experiences from it. This is an Amazon team member in a cornfield in Indiana at the Amazon wind farm called Fowler Ridge. This is one blade of a turbine. I'm gonna ask you guys for a show of hands again. How many of you have been close to a wind farm in person before? This is awesome. You guys have seen them before. So you guys don't need to tell me, I don't need to tell you guys how enormous these are at scale. There are 62 of these at this wind farm, 90 meters high. Tremendous. When you start driving up on the horizon and you start seeing these things, it is just truly amazing to see them. And the wind farm is a really cool thing because it's part of Amazon's journey to get to 100% renewable energy. We get to work with a reputable wind developer to help create a project, enable new renewable energy. It makes the grids greener. But as I drove up to the dedication ceremony to this wind farm, there's something that really resonated with me personally that I want to share with you guys. I was born and raised in South Dakota. You guys know where that is? Yeah. Zach. That was less hands for South Dakota than for the wind farms, which is pretty amazing. So anyway, I come from a farming family. My dad's side of the family is all farmers. My mom's side, we're all farmers. And it's really challenging to be a farmer in America today. And as I was driving through those small farms, I was like, wow, this is really amazing. I haven't been back in a cornfield in a long time because I live in the middle of downtown Seattle, Washington, where there is not a cornfield. And getting to the dedication ceremony for this wind farm, there's a small team of Amazon folks there. There was the development community there who'd help make the project possible. But the silent participants who made this project possible were the farmers where these wind turbines were actually placed. These wind farms take a small footprint in the farmer's field, so they don't have to worry too much about their crops being cannibalized by having these wind farms placed there, but they provide something really important to the small American farmer, and that is stable revenue. By having these wind farms in their fields, the farmers are able to get a revenue payment, a lease payment, if you will. So the really, really cool thing that I hadn't even really thought about a lot of times during this project development cycle was the impact we were beginning to have on the local community by doing these projects. And that was just so powerful because you go and sit in the ceremony where we did the kind of inauguration of this project, and it was all farmers whose lives were going to be changed because of this project. A really, really cool thing we strive to have in a lot of our projects. Similar story that I want to share with you is about the first solar farms that we did in Virginia. And the solar farms are interesting because they illustrate a principle that is part of AWS's renewable energy strategy. And that is, we want our actions, we want our impacts to be a multiplier. Because truly, the climate changes that we face as a company are not going to be solved by individual agents. It is going to take everybody. So when we make large-scale transactions in regions like Virginia or Indiana, we want to knock down barriers so that other large companies and individuals can make investments in renewable energy to further propagate renewable energy deployment, make it easier, faster, and more cost-effective to deploy renewable energy. And Virginia is a really, really cool case study. AWS has had data centers in Virginia for over 10 years. The interesting thing is there wasn't a lot of solar energy in the state of Virginia. In fact, in 2014, there was just a little over 10 megawatts of solar farms deployed in the state of Virginia. Amazon worked very hard to deploy solar energy in the state. Now we have 260 megawatts in the state of Virginia. Think about that in terms of scale, 14 megawatts to 260 megawatts. And it's not just Amazon now. Other tech companies are making investments in solar energy. The governor of Virginia has put in policy places to try and get more solar energy in Virginia. They are listening to customer demand. They are seeing our investments in solar energy and responding. In fact, Dominion, Virginia, which is the large utility in the state, has now issued a 500 megawatt RFP for more renewable energy. So what we see is that practices, we want to incentivize renewable energy development in state, and it's really powerful and amazing to see that happen in such short order. Similar story with the Amazon wind farm in North Carolina. This project, Desert Wind, is our largest project to date. It's the first utility-scale wind farm in the state of North Carolina. So think about that. Hadn't done a project that big. Can it be done? Yes, we worked with Iberdrola, a large wind developer, and that project went into production in December of 2016. The thing we recognize with renewable energy, though, is that this is a long journey. We are going to be making progress on this space, but to really push to 100% renewable energy, we're going to be looking at an integrated solution that includes enabling new projects, working with regulators, working with customers to find ways to get the grids greener, faster. And I'm really excited to share a story with you guys today about water usage, because this is a topic that doesn't get a lot of attention in the data center space. Those of you guys who carry around laptops and are not data center hardware engineers probably know that your laptop puts off a lot of heat if the fan's not working. If you've been in a data center before, you recognize that they can be hot operating environments. So a lot of times, we'll use water to cool these data centers. And we need this cooling to keep the temperatures at a parameter where the hardware doesn't get hurt. And we spend a lot of time thinking about how can we optimize the amount of water that we consume in our data centers. Well, how do we do that? Before we even think about going into new regions, we spent a lot of time evaluating climate patterns to determine the most energy and water efficient way that we can actually cool these data centers. And again, I'm going to harp on this point around innovation. Very important. At our scale, oftentimes we'll do unique things. For example, in Northern Virginia, AWS was the first data center operator that was approved to use recycled water with direct evaporative cooling technology. Now that's a pretty amazing thing, because if you think about a world of water scarcity, you certainly don't want to be using potable water, the type that we drink, to be cooling things. You want to use recycled water. And AWS has made that commitment to use gray water, recycled technology in our data centers where possible. And in fact, in the Oregon region, AWS data centers partnered with a local utility to use non-potable water for up to 8 of our new data centers. So we have a saying. We say that the greenest electron is the one that you do not consume. Wind turbines, solar farms, those are very, very powerful optics. They're beautiful, they're impactful, but it all starts with energy efficiency. That is truly ground zero for anything that you want to do around sustainability. And I want to talk a little bit about data centers operating at scale and what that efficiency means. And a great way to do that I've found from talking with energy regulators, utility commissioners, power plant developers, is to share a story from my own experience. So in 2006, when AWS was starting, I was working in a consulting firm. And those of you who have worked in legal services or in consulting know that oftentimes you have non-billable hours. Anyone familiar with non-billable hour activities? Yeah, not super fun. And my non-billable activity was the IT sector for my company. Now that sounds kind of glamorous and fun, but I'll tell you what it really meant. It meant that on every Friday, I went into our broom closet where we had our server rack. And that server rack put off a tremendous amount of heat. So how we cooled this using state-of-the-art technology was to use one of those old little air conditioners that had a little evap tank on it with one of those white insulator pipes that blew cold air onto our server rack. So every Friday I would go check, and during the summertime I had to do it every day, dump the water out to make sure that we weren't going to spill water over the server room, and check on the air conditioner and make sure the temperature was okay with there. One, does that sound like a really reliable, safe operating experiment, like atmosphere? Or, it wasn't the best environment to have our entire consultancy's network sitting on. And as a young consultant, I can tell you that it was a very, very scary experience to have to go into that room where there's power and water floating around and do that. It occurred to me later in my career how inefficient that was. First of all, if you think about the fixed cost that went into that server rack that's going to depreciate over 3 years and it's sitting in a cooling room being utilized at maybe 10%, then think of how much power we were using to blow cold air on it, to power that thing. If you extend that experience, that server rack that was sitting in this broom closet at the consultancy I worked with, to on-premise data centers, on-premise compute versus cloud, you start to see a really powerful story about efficiency, and you understand why we really believe that the greenest electron is the one that you don't use. Because if you start looking at the utilization rates of servers on-prem versus using a cloud-based solution like AWS, you start finding you get high degrees of utilization because you're only using what you want to. In addition, we have a metric in the industry called PUE, power utilization effectiveness. Basically, if you get to 1 at PUE, that means that you are being very efficient about using energy within your data center. The PUE of I'm scared to think of what the PUE was at the consultancy I worked at, probably double digit at some point, just terrible. But when you start looking at world-class data center operations, you're talking about 1.07 to 1.15. When you start extrapolating that out, higher degrees of utilization, higher energy use effectiveness, you can see tremendous reduction in power consumption. That means two things. One, it means that you spend a lot less money operating your compute. And there's another element to this that's really important. Your carbon footprint goes down significantly by using more effective energy. When you combine it with the fact that AWS is making investments to green up its power consumption, you start seeing this net benefit that's quite tremendous in carbon footprint reduction. And we've just gotten started in this space. I can really see in the fullness of time, as we get to more and more efficient data center use, more and more renewable energy consumption, you're going to see these numbers just get better. In addition, it's not just energy. It's just not how we engineer and build our data centers. It's also a high degree of innovation and customization at every layer within the data center, including the infrastructure that we used. And I don't know if any of you guys had a chance to see Peter's note last night, but he talked a lot about the history of networking gear. And it was a really, really cool story because it illustrated the point that at Amazon, that we're always innovating, and not just in software. We are a company of builders and pioneers. And oftentimes what we find is if things are not working the way that we want them to, we will go roll our sleeves up and build them ourselves. And you see that in chips, you see that in servers, and you see that across our global infrastructure. Great example was talking about network gear. Previously, network gear OEMs were optimized for mass consumption. They had general designs that were burdened with a lot of unnecessary features. A lot of times that I'll explain this if you're not a networking engineer or expert, is when you buy a new laptop and you open it up and immediately get popped up with 27 different bloatware pieces of software that you don't need. Imagine that same problem percolated across hardware. You don't need all those features. And oftentimes those features that did not help customers made it more expensive to have in a distribution network. And introduces degrees of complexity. And anyone will tell you that increased complexity makes maintenance and cost higher. So what do? We set about building our own custom servers. And this provides a lot of benefits. Some of them you might not even think about, but are worth talking about. For example, when you operate at the scale that AWS does, your supply chain is tremendously important. So we work directly with component manufacturers on commodity elements like hard drives, memories, and CPU to design specific components where we can control the cost and the quality of those units to put into our custom-built servers. What that also does is you can optimize those servers for specific workloads, which means you know exactly how they're going to operate under environments, which produces high degrees of reliability at lower costs for servers and customers, and allows you to innovate and experiment with new ideas in a much faster environment. And finally, they're highly utilized. And that becomes really important when you start thinking about using compute at scale. So finally, why AWS Global Infrastructure? You guys are all here today at reInvent. You're seeing our scale and the pace of innovation, the new services that we're announcing around infrastructure, Ground Station, the Global Accelerator, the AWS Transit Gateway. You can continue to see that spirit of innovation in our infrastructure, that high degree of customization at every layer of infrastructure, from servers, from chips, from softwares, from our data centers, from our global network, as we continue to grow and serve our customers. You will see that spirit of innovation on every dimension of our data centers. And with that, I would like to say thank you guys very much for making my first reInvent a really, really awesome and fun experience.